And recognizing, guys, when it's in like a geometric form or how we can work with that general term. So it's kind of wild, but we got another day, so we'll be okay, you know. This one, I put this one on here. It's not like particularly super hard, but people do like weird things on it. So it says like g of x is x plus 1 times sine of x, which is like really horrible because if it's like just x squared, that's like so much easier. But since it's like a binomial like that, you're going to have to be doing like distributing in an infinite series. So it's like first of all, that's already hard to like wrap your brain around. But the savior is that it says the first three. Okay, so it's not like you're gonna come up with like a general or like have to do like 80 terms. You're just gonna have to do the first three. So I'll show you like my strategy for it. Like I'll write out sine because that's like one I know. So like sine of x equals x minus x cubed over 3 factorial plus x to the 5th over 5 factorial. You know, like blah, 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 okay? Plus, and then technically we have a general term, but we're not needing to do that. I mean, I guess I'll just write it for fun, but 2n plus 1 all over 2n plus 1 factorial. So that's sine, but like I said, we only need the first three. So I don't really need to deal with this, okay? So don't freak yourself out over it. But then now to find g of x, you're gonna have to distribute this x plus 1 thing times sine x. Okay, so it's basically like doing x plus 1 times like this that goes on forever, which might make you want to cry. Plus dot, you know, I don't need the 7. I'll show you why in a second. Okay, so I'm going to have to like distribute the x. Do you know what I mean? And then you're going to have to do distributing the 1. And it's going to be like, what is happening to my life? Okay, but we only need the first three. So that means I need them in like order. So you want the lowest degree first. So I'm not going to need like x to the 20th power or 7th power. So what I mean is if I were to like do this a little bit more, I'll do green, I guess. So I'll go like, if I do x times x, I'll get x squared. And I do just like a couple of them. Actually, I'm going to do subtract. I'm going to just do a couple of them. So what would that be? X to the 4th over 3 factorial plus x to the 5th over 5 factorial. Like, you know what I mean? And obviously I keep going. Technically, I would keep going. Okay. Oh, yeah. Sorry. We're continuing on my not being able to add. Okay, so, yeah, it's fine. And then, so anyway, you would like keep going with the x, theoretically. Okay, but then what the trick is to start writing the next one, like start distributing the 1. So like technically the x would keep going. And then now I'm going to do the 1. So that would be x, right, minus x cubed over 3 plus x to the 5th over 5 factorial. And then technically it would keep going, right? But I only need the first 3 non-zero terms. So you just go least to greatest on the power, you know what I mean, on the powers. So you're going to take some from the 1 and some from the x being distributed, and you just put them in order. So I just do enough to get a vibe of what it's going to be, you know, until I can get, so before my powers get too wild or too big. So then basically what my answer would be is what, x And then I'm going to take 1 from the 1. I'll take this x squared. And then the cube 1. So that's the first 3 terms. So that's all I have to do. So. And then you can clean up. You can change that to a 6. Sometimes they change it to a 6. Sometimes they leave it as factorial. It kind of depends. So, is there any questions with that? Okay. All right. This one is like hurts the brain. When you look at that, they give you g of x equals 3 to the x to the n, where absolute value of x is less than 1. Find an expression for the function of g. So I actually have to find like an equation. Like what? You know? So what you want to notice from here is being like, hey, it's geometric-y. Did you know? The 3, whatever. But x, you know how x, you plug numbers into it, right? So you're plugging numbers into x to the nth power. So this is like a geometric-y looking series is what you have to notice from it. Okay, so like side note, remember the geometric, we did that. This is like technically the formula for it, right? That was the formula. And then you would take, to find the sum of a geometric series, remember it was like the first term over 1 minus r. So you'd always do like the a over, I think these were the same colors I did. 1 over 1 minus r, right, to find the sum. This represents the equation for g, right? So that's like, if they say they want a function for g, this means a sum. And because it's geometric, I can actually find the sum, and this is what like the formula is going to look like. Okay, so what I do for this, couple ways you could think about it. There's 2 ways to do it. Okay, so depending on your brain. Okay, first thing you can notice is, like I said, it's geometric and kind of go off of this vibe. Okay, so I would be like, okay, my first term is if I were to plug 0 in for n, right? Because you're starting at 0, plug 0 in for n, and I get 3. So that would be my a, right? And then your r is like what's raised to the n. So like here's your a, ends up being, and then here's your r, right? Because that's like the number raised to the n. So then you could be like, oh, my r equals x. Okay, because there's not numbers in it yet. We're still going to like plug in numbers into it. And then what you can do is just use like the formula for the sum, right? So this is like unit 9 stuff where you would do like, okay, put the first term over and then go 1 minus your r, which is x. So that's your g of x. That's your answer. Okay, that's one way to do it. Okay. The other way to do this, so this is more if unit 9 was your vibe. Do it this way, okay? The other way to do it is to recognize the series itself, the 3x to the n, and be like, hey, I know things where I know the Maclaurin series for x to the n is 1 over 1 minus x. Because that's like in my head from the Maclaurin. That was the first one on the list, right? So you could do it that way and be like, oh, there's just being a 3 multiplied to it. So if I need to find 3, I just multiply that series by 3. So that's another way to get it. So it kind of depends on the brain, whichever one you want to do, okay? They usually vibe with this strategy, okay? Because otherwise, like for other series, you can't do this unless it's geometric. Because geometric's the only one with like the formula, I know, to find the sum. If you're doing like other things, you can't do it. So knowing them is really helpful, okay? So like number 4, you have to do it, I would say, well, I guess you could do either way, I guess. Because for here, let h of x is 12 over x plus or 3 plus x. Find the power series for h centered at x equals 0. So what you want to notice here, it's very close to looking geometric. Do you see what I mean? Like it looks like this formula? Kind of. Like it's still far off. Because like, okay, 12 would be fine, but there's not a 1, and it's a plus. But I could like force it to make it look geometric-y. So it looks, that's what I wrote, looks geometric-y. That's what goes on in my brain. Geometric-y, that's a word, just go with it. Okay, so like again, the way you can manipulate it is your goal is to make it look like the S equals A over 1 minus R thing. You want it in that form. So then you can find like the series, because now we're going backwards. We're given the equation, now we got to get the series for it. So I'm going to mess with it. So the 12 I don't really need to deal with because that could just be my A. You know what I mean? Because that's already fine. Like I can have a number as A. That's not a big deal. But I don't want the 3 there. The 3's killing my vibe. Okay, so to get rid of the 3, I'm just going to do some algebra to it. As in, I'm going to multiply the denominator by a third. Because wouldn't that make it a 1 if I distributed the 1/3, right? But I got to keep it legal and make sure I multiply the numerator by a third. You can't just go multiplying random stuff. You got to keep it legit. So 1/3 divided by 1/3 is 1. That's why it's like a fancy looking 1. And then what I get is 4. Then I have the 1. And then I have this like x over 3 thing. Right? And then the last step is I don't want the plus thing, I want the minus thing, right? So I got the 1, but now I need it minus r. Well, that's kind of not that horrible of a fix because you just make it negative. So just go 4 over 1, but then change it to like minus a negative. Do you know what I mean? Like that one's pretty easy to do. And then now it's in like the form of it. And you can extract from the equation the A and the R because then you can put it into the series format for geometric series. So you relook at it and be like, okay, my A is 4, and then my R is this thing, negative x over 3. So I tried to get it into that form. So again, this is like, remember this is A over the 1 minus R thing. And that was like the whole point of doing all that algebra junk. Because then now I can make the actual series. So h of x, I can now write as a series, which is what they want. N doing 0, I'm not going to be weird and start at 1. And then I'm going to put 4 in because that's my A. And then remember it's always the R to the nth, whatever. And I'm going to plug in negative x over 3. So that would be the series for it. I guess that's the general. And then if they told you to write out some terms, okay, for it, you'd plug in 0, plug in 1, plug in 2, plug in 3. So if I did write out the actual series, it would be 4. And then if I plugged in 1, it would be minus 4/3 x. And then if I plugged in 2, that would be what? 4x squared over 9, ... So sometimes they make you like write it in this form, where they write it out with the terms. Sometimes they just have the general. So it kind of depends on what they want. Sometimes they get stingy on the domain. So like on multiple choice, they'll have 2 of these, like they'll be both the same answers, but then they'll vary on the range. So again, going back to Unit 9, okay, how do you know the series converges for a geometric series? This is where you might start crying, we'll see. It's when the radius is less than 1, right? That's when it converges. Right? Because you would take the radius. Maybe I'll put this in the dark blue again. So again, it's like, oh, pull that out of your brain real quick, okay? This is how you converge on a geometric series. So this series converges, okay, when you have -1 x over 3 to 1. So between -3 and 3. So like on multiple choice, they might give you this. Like this would be A and B. Do you know what I'm saying? Like the series would be. Like you'd have the correct series for both. So at least you know it's one of those. But then you'd have to figure out, they'll give you like where x is between -1 and 1, or when x is between -3 and 3. Like those would be your options or something. So you have to go back to Unit 9 to kind of like revisit all that.
This is going to sound dumb, but do you have to check them to see?
No, nope, you can just leave it because we already narrowed it down to being geometric and forced it to. We don't need to do like the whole like interval of convergence thing. Those are for like series we don't know about, if that makes sense. Whereas this one, we're like, it's geometric, this is the rule, yada yada.
Okay.
No, that's a good question. Then I run out of room also too, so you know, that's a thing. All right, so now this next guy, okay, write the first 3 terms. If it's FRQ, this is part A. I've seen FRQs like this. That's the best A. Do you know what I'm saying? Where you just need to plug in. So don't get it wrong because you get like an easy point for it. So h of x, the first 3 terms. Oh, don't be the kid who messes up where it starts. So make sure you start at 1. Do you know what I mean? Because that's where series starts. So you're going to plug 1 in for n. So if n equals 1, you're left with what? Just x? Right? And then if n equals 2, you get x squared over 4. And then if you get n equals 3, you would get x cubed over 9. Okay? So that's like the best one, where you just have to write 3 terms. And you're like, cool, loving life. Okay, now this one says write the first 3 terms and the general. Oh, for crying out loud. I'd rather they just... Okay, so this is what I'm thinking. I have to take the derivative now. Isn't that fun? So if I need 3 terms, I'm kind of looking ahead. These are polynomials, right? So I'm thinking like, all right, think of what the derivative of that is, derivative of that is, derivative of that is, and then I'm going to do the general term, but remember the general term is just up here. Okay, so what I'm going to do for h prime, okay, you're going to take the derivative of x, which is 1, right? And then this one would be what? 2x over 4. I know I'm showing a lot of work, but just go with it. I'm going to show it like this because it'll help you with the general term. And then this one would be 3x squared over 9. And then I got to do the general term. So you want to pay attention to like what you're doing. I mean, it really comes down to you are not manipulating the denominator, technically, right? I didn't simplify it, that's why. Because you're noticing like the 4 and the 9, that's not changing. That's why you're not changing n squared. That's going to stay. Because nothing's happening with the n's on the bottom. Yeah, you reduce it later, but it's not like, it's not being affected by the derivative. The only thing that's being affected is the x. So think about the formula for derivative. It would be n, right? X to the n minus 1. Isn't that how you find the derivative of a polynomial? You bring the power down and subtract 1, and then the n squared, nothing happened to it. But you do reduce it, right? So I usually, even though it feels dumb when you first do it, like do the derivative like super like first step-y. Don't simplify anything, because then it helps you deal with this one, like seeing the pattern. Because then when you actually reduce it, you get 1, and then you can be like, okay, fractions are cool. You know, oops, why do I keep doing that? There we go. And then you can see how one of the ends cancel in the general. So this would be your answer. First 3 terms and the general. Any questions? Okay, ready to juice it a little? Because look at the general term on number 6. Ew! Okay, so write the first 3 terms and the general term for f prime. So same thing, don't be wild with it like on the first step. Like even though it feels dumb at first, just write it. I'm going to switch to pink because it's fun. Okay, so if you take the derivative, again, don't start simplifying. Like just write 15x cubed over 3 factorial. A lot of your guys' brains are smart for that, simplifying that so fast. Why do I keep not knowing how to subtract today? Sorry. Oh, first 3. Yeah, that's not, why are we doing that? And the general. Let's not do this. Good save, everyone. Okay, so basically I brought the power down. And again, the factorial junk didn't get mixed up, right? So all the end stuff, leave it, okay? The only thing we're really focusing on when you're doing a derivative is this little xy guy, right? So you have this like psycho thing, n plus 1, n plus 2. And then for the, or maybe I'll put that in a different color. For this derivative part, right, that would be nx to the n minus 1, and then all over n factorial. So then your next step is simplifying, and that last step might be a little scary, we'll see. 3 minus 4x plus 15, is that 5 halves, I think? Yeah. Dot, 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 dot. Oh. I took the one of the 3's out of the 15. Okay. And then this guy, the numerator should stay. Okay, but I actually can simplify out one of the ends. Do you know what the denominator would be?
N minus 1 factorial.
Yes. What a champ. Yes. Because think about what n factorial is. That's this, right? Here, I'll give you a sec to process. I wrote a lot of stuff. I know, but it is. But you know what I'm saying? Like they took an n out of one in the line. So they took the first n out. So now you have n minus 1, n minus 2, n minus 3, blah, blah, blah. So you can write as n minus 1 factorial. So good times, hey? Any questions so far? Okay. I mean, if we're doing derivatives, why don't we integrate? You know what I mean? All right. So now we're going to integrate. So k of x. Now I need to do f of t. Okay, so if I'm going to integrate, that's going to be 3 halves x squared, right? Minus 2/3 x cubed plus, now this is where my factorials get like a little dicey, you know what I mean? I'm like, ooh, now I'm getting scared. Okay? So, and you want to write it like stupid, the first line. Do you know what I'm saying? Like no simplifying, just doing the power stuff. So like this one, you know how x cubed would go to x to the 4th, right? So you would divide, you would have to multiply or divide by a 4, right? If you increase the power. So I'm just going to write it like stupid. It's not stupid, but you know what I'm saying. Because then you'll be able to see what's happening when you deal with the general, theoretically, right? Okay. Is everyone oh gosh, you guys, I'm really having problems with exponents today. Okay, so antiderivative of this guy is to the 4th divide by 4. So I just kind of put it up front. Okay. So when you do the general term, factorial junk didn't get mixed up. I might simplify it later. We'll see what happens. But again, all of it is focused on this x to the n. So it's like this -1, n plus 1, n plus 2. Because the n's are just numbers. You know, like get in all the terms. This is all over n factorial. And then you're going back to your roots of what is like an antiderivative, right? You take your x and you add 1 to it, the power, and you divide by the new power, right? So it'd be n plus 1. That would be doing like just straight up the x part of it for an antiderivative. So now I can clean it up a little bit. And this one I've seen written with the factorial. And you know what they changed the third term to? 4 factorial. You see it? Because it's 4 and then 3, 2, 1. So I've seen them simplify it. I've seen them simplify it, but I've also seen them leave it as a factorial. So I feel like the multiplying the numbers is easy for you guys. Like it'd be 24, right? Okay, it'd be done. But like the 4 factorial, it's because it's 4 times and then 3 times 2 times 1. And it helps you understand this general guy. Because this denom I can mess with. Because it's the same idea. Because this denominator is n plus 1 factorial. Get it? Because think about it. This one would be n plus 1, and then it would be n minus 1, n minus 2, n minus 3. This is like the term before it. I should have wrote it in the beginning. It's just like this 4. 4 times 3 factorial. One more extra. Okay.
And it was like the integral was x, like x squared to 1. How would that change?
Or if it was x squared.
If it wasn't x.
X to the 2n, say, or something. It would still be x to the 2n plus 1, and then divide by 2n plus 1 would be the antiderivative. Because you always add to the power, divide by the new one. Yeah. All right, this guy. Now, this is a thing that you should recognize out of your brain. Okay? So, yeah, did we recognize? Was this on the homework, really?
That was, but not like this.
You have to recognize, hey, that's the derivative of that. A series I know.
Wait, shouldn't it be negative?
Nope. I should just know. I know it. I know it'll be negative. Just hold the phone. I know this. Or, whoops. I know it's this, right? No, because of chain. It doesn't work. Because it's -1 and then the negative x. Here, I'll write it off to the side. If you took the derivative of 1 minus x to the -1, right?
Oh, yeah, the negative.
It'd be -1 x to the minus, oh my gosh.
I get it.
Well, hold on.
Hold on.
Hold on.
Let me finish telling you why you're wrong.
So this one, if I took the derivative of this, I would bring down the -1, do -2, and then chain it. Right? So that ends up being, it's +1, -1 times -1 over 1 minus x quantity squared. Right? And because you guys are like next level smart, right? Right? Okay? You can be like, oh, duh, the derivative of 1 minus x. 1 over 1 minus x is that. So all I need to do is write the series for this and then just take the derivative. I just know to do that. So you have to have your Maclaurens down so good that when you look at a rando, you can be like, oh, I can do stuff to one of my OGs to get it to that.
Were we gonna, is it gonna,
Yes.
would it be like, oh, that's the integrated?
Yes. Yes. Yes, that's tomorrow. Yeah.
That's possible.
Yes.
Why can't you just split it up into 1 over 1 minus x times 1 over 1 minus x and just do it?
Yes, but that involves distributing a series. Do you know what I'm saying? Because then you're like,
It's more complicated.
yes, it's more complicated. But technically that would work.
Okay.
But you would hate your life.
Okay.
Does that make sense? Okay. So, like for real, I feel like I would. So anyway, but this, you could be like, oh my gosh, I know it. And they want a whole representation. They don't want 3 terms. They want like a full shebang, right? So I need the full general, everything. Okay? So again, how do I know? It's like, ooh, that looks like one of my OGs. It looks like one of those. All I need to do is be like, oh, hey, the derivative of 1 minus x is f of x. Oh my gosh, I'm the smartest person alive. Okay? So then you can be like, oh, hey, f of x, right, is the derivative, I know I'm kind of rewriting this again, but we're just going to do it, of that series. And then now you're just going to take the derivative of it. And then that's your f of x. Okay, so the derivative of that is my function that I want, right? And I'm just going to take the derivative. And then for the last term, you do like normal deriv style, like bring the power down. So you're going to bring n down. And then you subtract the power, n minus 1. So honestly, the recognition is the part that like makes you want to cry. Because once you know what you want to do, I mean, taking the derivative, that's not hard. It's just getting to that point,